Okay, hello and welcome back to our lesson on parallax sonic sensors and using them with PIC microcontrollers. In this lesson, or in this part 2, we will be looking at the code, the C source code, on how to establish what we were doing here. And for those of you who missed it, what we were going to do is we were going to have basically our sonic sensor. You're going to be able to place an object in front of the sonic sensor, press this switch, and which will then store the location of the object in memory, or at least the distance that it was sitting away from the sensor in memory. And then if you place the object in that distance or closer to the sensor, it will light this LED. If you move the object far away from that distance that was stored, it will extinguish the LED. So basically very simple programming, but at least it will show you how to configure your microchip PICs for reading and sending data to these systems. So let's go ahead and get into it. What we have is we've got a 16F886 chip, got our fuses, we've got our pins laid out. We've got pin B1 as our signal pin. We've got pin A5 as our set switch. We've got pin C4 as our LED. Now we're setting a 4 megahertz internal clock, so that way we can perform our delay functions, get the timing down. And so let's go ahead and jump into the function I've created for the sonic sensor to read it. So I named it sonar. You basically got a timer variable that will count how many basically intervals that have passed to measure the timing of the echo response, so we can get a bearing on the distance. First things first, we're going to set up the tri-state registers for all output, because we will send our burst out, or our positive pulse out first, so it needs to be set up in output mode. So we do that with the set tris command. We output a low to make sure it's low, and then we output our high. And then what we do is we'll delay for 5 microseconds, because in the let's see if I can bring it up here. In this manual, let's see where we're at. Here we go. It talks about that the T out, basically the length of your pulse, needs to be anywhere from 2 microseconds to 5 microseconds. So what I did was I just went to the upper one, made sure that it got a nice good long pulse, so I give it 5 microseconds, and then I go low. So basically we're right here now. So once it goes low, it's going to send out a chirp, and that chirp will then come out, and then it will go high. Well, for this dead space here, we're going to just set a while loop. And basically what this will do is while the input is low, it's just going to stall. We're just going to stall right here and wait for this edge to go up. And then the minute it sees this edge go up, we're going to then go into a new while loop. That's while it is high, we're going to then start counting our timing. We're going to delay every 5 microseconds, and then we'll add one to we'll increment this timer variable every time we loop. So basically we're going to be counting in 5, 10, 15, 20, 25, like that. Multiples of 5 microseconds. So basically when we're in here, it's going to go high, our while loop's going to see that. We're going to go 5, 10, 15, 20, 30, all the way up to however long this pulse is, and then the minute this goes low, the while loop will exit. And it will return the number of iterations of 5 microseconds is what it will return. So basically if we look at our main function, this will tie all of this together. We're going to set up our tri-state registers in A, as port 5 is going to be an input because of if I can get the schematic back up here. Okay, we got 5. So we're going to set that up as an input. And then we've got all outputs everywhere else. And so that's how we're going to do that. And then we've got 2 variables. We've got present and check. What present is that's basically the stored. It will be the stored one. Check will be the one that will be checked all the time to make sure and it will check the variable check against present. So we're going to output low on our LED, initialize it as off. Then we are in our for loop, our infinite for loop. We're going to say while the input button is pressed, basically, because we're using kind of a negative logic, it's pulled high all the time until we press the button. So basically if you push the button, it's then going to store whatever the sensor sees in the variable named present. Then we're going to check again. We're going to start storing When you let off the button, it's just going to run this, and it's going to start storing whatever the sensor's seeing in check. And then we're going to basically check it against present. We're going to see if it's less than or equal to present, which means that is it at where present was or closer to the sensor. And if it is, we're going to output high. If not, we'll output low. Fairly simple. And I think I'll go ahead and build this. We'll go ahead here. Yeah, and we have 0 errors, 0 warnings. Okay. But I think I'm going to go ahead and build this on a breadboard just and give you guys another demonstration. I kind of, it's fun to make these videos and show you one piece and the other, but it's kind of nice. I've been on you guys' end, and it's kind of nice to see it actually work, so that because I know a lot of times I've copied code, literally line by line, and hooked things up exactly the way they've said it, and compiled it, put it on, and tested it, and it doesn't work. So I think I enjoy seeing it actually work, seeing the code actually go on and work. So that's what I'd like to do for you guys. So I think I'm going to go ahead and build this, put it on a breadboard, and show you guys it working. So any other questions, feel free to comment. Any types of questions or anything you may have, we'll do that. We'll look to the future. I think what we'll do probably coming up, we'll do some real-time clocks using the Dallas Semiconductor DS1307 by Maxim Technologies. We'll probably look at doing that, which that uses the I2C bus. If you guys have ever wondered how to do that, we'll be doing that. We'll also write to external EEPROM memory. Sometimes that's nice because a lot of times, the chips themselves, especially the 8-bit microcontrollers, don't have a lot of EEPROM memory on board, so you like to add an external chip that uses also the I2C bus. I'll also show you the kind of the master-slave stuff. We'll use the external EEPROM memory along with the DS1307. That'll be another lesson where we incorporate the two of them and show you how to do the master-slave stuff with the I2C protocol. So some cool stuff coming up. Please subscribe. Please comment with any questions or concerns that you have. And I'll be looking to talk to you later. Thanks.